Assemblers have their own instructions which are called the assembler directives. They are not 8086 instructions. These directives are pseudo instructions, that is, they are not translated into 8086 machine codes. They are giving only the directions for converting the 8086 instructions into machine codes. In this second part of 8086 assembler directives video, I am going to explain 14 important directives of 8086 assembler. The next directive is equate, that is EQU. This directive is used to define symbolic constants. It will be very useful to define port addresses and control words of the peripheral ICs, which will not be changed, or they should not be changed by the assembler. You can define the constants like this: port 1 equate 8000H. So whenever you use the word port 1 in your program, that will be replaced by 8000H. Then this is defined byte. Defined byte helps to represent byte data using name. Actually, those names will be variables. It will allocate memory locations. While assembling, these names are replaced by values. For example, A1 defined by 10. So the variable A1 is defined and initialized with decimal value 10. Here B1 defined by 0AH. 0A is the hexadecimal number. It is a 8-bit binary number that will be assigned to B1 variable. The next one is C1 defined by 10, 11, 12, 13. That means C1 is an array of 4 bytes, and that C1 will be initialized with these 4 values. Then D1 defined by 10 duplicate within brackets question mark. This indicates that D1 is a variable and 10 bytes will be allocated to D1, but these bytes are not initialized with any value. In the next case, E1 defined by 10 duplicate within brackets 0. That means 10 bytes of memory will be allocated and they will be initialized with 0. Then F1 defined by within double quotes KKT. That means the string KKT will be assigned to F1. That means each character will require 1 byte. So 3 bytes will be allocated and they will be initialized with KKT. The next directive is define word. A word is nothing but 2 bytes or 16-bit value. So define word helps to allocate 16 bits or 2 bytes. For example, a define word 1, 2, 3, 4. These are the hexadecimal digits. 2 hexadecimal digits will require 1 byte. So this number 1, 2, 3, 4 H, 4 digits are there. So 2 bytes will be required. That means 1 word, and that 1 word will be allocated and initialized with 1, 2, 3, 4 H. D define word 10 duplicate within brackets question mark. That means you have to allocate spaces for 10 words. 10 words means 10 into 2, 20 bytes. So 20 bytes will be allocated to the variable D, but no values will be stored in that. That means it is not initialized. The next assembler directive is define double word, DD. Since 8086 is a 16-bit processor, one word is equal to 16 bits or 2 bytes. So a double word means 4 bytes. For example, ADD 1, 2, 3, 4, 5, 6, 7, 8. That means this is 1 byte, 2 byte, third byte, fourth byte. Because using 1 byte, you can store 2 hexadecimal digits. So now you have 8 hexadecimal digits. That means the length of this value is 4 bytes. So 4 bytes will be allocated to A, and this value will be stored in that A. Then next one is define quadruple word. Quadruple word means 8 bytes or 4 16-bit words that will be stored in A. Similarly, DT is used to define 10 words. Similar to the subroutine or function you are using in high-level languages, in this assembler also you can write subroutines or functions, but in 8086 it is called as procedure. Any procedure should start with this PROC directive and it should end with end P, that means end procedure. The procedure may be provided in the same segment or it may be provided in another segment. If the procedure is defined in the same segment and used in the same segment, then that procedure should be defined as PROC near. If the procedure is defined in another segment and used in some other segment, then that procedure should be defined as procedure for. And this is the procedure name. So the syntax is like this: procedure name, PROC, then near or for. Then at the end of the procedure, you have to put this directive end procedure. The next directive is even. This instruction directs the assembler to store a word or double word starting at an even address. When a value is stored starting from even address, it can be accessed by the 8086 in single clock cycle. If the same value starts at an odd address, then the microprocessor will read it using 2 clock cycles. So this even instruction instructs the assembler to store a word or double word starting at an even address. If names or labels or procedures are defined in one segment and they are to be accessed in all other segments, then they should be defined as public and for. Here, this is the procedure. It is declared as public and it is also declared as for procedure. So it can be accessed by the program written in any segment. If the names, labels, or procedures are defined in another segment and they are to be used in the current segment, then they should be declared as external and for segment. That means they are available in another segment. If the variables or arrays or procedures are declared as local, then they may be used only within that segment. The next directive is byte pointer or word pointer. This directive instructs that whether a byte or a word is to be used when registers provide offset address. For example, move AL, byte pointer SI. Actually, SI will be giving the offset address. This offset address will be combined with the data segment, and from that 20-bit address, one byte may be brought or one word may be brought to the register, or even a double word may be brought to indicate that whether we have to bring one byte or one word, we have to use this directive byte pointer. That means it will bring only one byte and it will put it in AL. If you use word pointer here, then one word, that is 2 bytes, will be brought. In that case, instead of AL, you should put AX. Another directive is short. For example, jump short label. So this is the address. If this jump address is within the range of minus 128 to plus 127 bytes, then it is a short jump. In that case, it should be specified as short. Otherwise, 16-bit jump address will be used. If a variable or constant or label or procedure is declared as global, then they may be used in any module or any segment. Routine is the procedure name. So you have to use procedure directive and global directive also. In that case, this routine, the procedure named routine, may be accessed by any segment or any module.